Hi, I'm Paul. We're doing Leetcode must know interview questions. Today's challenge is the lowest common ancestor of a binary tree. So given a binary tree, find the lowest common ancestor of two given nodes in the tree. All right, so what is the input here? Let me scoot this over to see it. All right, so we're given a pointer to a root node in a tree. We're given a pointer to node P and node Q. I haven't seen the problem this way before. I've seen a root and then two values, but I think we should be able to do this the same way that I want to do it. Okay, the lowest common ancestor is defined between two nodes P and Q as the lowest node in T that has both P and Q as descendants. We allow a node to be a descendant of itself. All right. Example. This example is probably too simple to be useful, but we have a pointer to a tree, and then P is 5 and Q is 1. Oh, that's strange. Well, I guess it's still coming in as nodes, although they're ints here. All right, P is 5, Q is 1, so the lowest common ancestor of 5 and 1 is 3. Okay. Let's try this. I need a pen for this. And we'll do that. Okay. So this one, what do we have? 5 and 4. Okay, so 5 is 5 is here right under 3. 4 is down here at the bottom of the tree. One way to do this is not the way that we're going to do it, but I'll give you an alternative way of doing it is any way that you want to, you can create an array, or, well, let's not say an array. In this case, let's say a list from the root to the node. You'll have two lists. So first we need a list from 3 to 5. So we'll start here. We've got 3 and we've got 5. All right. Now we need a list from 3 to 4, and to get from 3 to 4, you would go 3, 5, 2, and 4. Okay? Then you look through these lists, and you see where is the first place that they don't match. The first place that they don't match is right here. Back up a node. That's the lowest common ancestor. In this case, 5. Now, a node can be an ancestor of itself, so 5 is the ancestor of 5 and 4. All right. Now let's talk about the way that we are going to do it. Let me think if I need to draw this. Okay, there's not really that much drawing here, but in this case, we are going to do it with a single traversal rather than look for one number and then look for the second number. So in this case, let's say we'll start on the left tree, and we're going to look for either 4 or 5. All right, well, we find it right away, 5. It's right here. And then we stop. And we say that's it for the left tree. And then we go to the right tree. And this applies at any node as you go down the tree. Then on the right tree, we're looking for 5 or 4. It's not there. Now, what happens is if you look from a node at its left subtree and right subtree, and you only get a result from one of the subtrees, then this node is going to be the lowest common ancestor, because the other number has to be underneath it somewhere. It's not in the right subtree, so it's got to be underneath this. Now, if you do get a find one number in the left in the left subtree and another number in the right subtree, then the root node would be the lowest common ancestor. And this applies at any node. I mean, if we had 7 and 4, for example, we would go from 3, we would go to 5. That's not anything we're looking for. We would go to 6. That's not what we're looking for. We would go to 2. That is not what we're looking for. We would go to 7. That is what we're looking for. All right. And then we would go back up and we would look at the right subtree of 2 and we would find 4. And that is what we're looking for. So if you get a return node from both the right and left subtree, then that node would be the lowest common ancestor. So that's the way that we're going to approach it. All right, let's try and do an implementation. All right, we're doing this recursively, so we need a base case. Base case would be if node equals null, return null. The root, this doesn't refer to the root of the tree because that is guaranteed not to be null, if I remember correctly. Let's see, number of nodes in the tree is in the range 2 to 10 to the 5th, 100,000. So there's at least 2 nodes in the tree. But it is possible as we navigate the tree that we're going to get to null, we're going to get to null nodes. Where are we going to get to null nodes? For example, if we, let's say the example where we were looking for 7 and 4, eventually we're going to go down here and we're going to say, all right, let me see what's in the left subtree. Oh, it's null. Right subtree, it's null. All right, so that just applies to lower nodes in the tree. We're doing it recursively, so we need a base case. And that's it. Node equals null. Stop. If node, oh, wait, whoa. Oh, okay, hold on. Okay, whoa. I just noticed this is coming in, it's called root. That's probably okay, because I don't think I'm going to change it. Okay. Yeah, no, I think it's okay, but we'll call it root. Sorry. All right, so if root equals P or root equals Q, I think the double equals is going to work here. I think it's going to work. If it isn't, then we'll come back and fix it. But okay, root equals P, root equals Q. Actually, let me scoot this over so we can see the tree at the same time. If root equals P or root equals Q, well, imagine kind of going through this and say we were looking for 5 and 4 in this example. That doesn't equal 5 or 4. It equals 3. So in that case, we'll do a tree node. No. If it is equal, we just return it. Return root. That was actually the case in the first example. They said, well, find 5 and 1. No, actually, I'm getting confused again. Okay. Okay, no, let's go on. I'll come back to that. If root is, okay, return the root. Otherwise, we're going to look at the left subtree and the right subtree. So left LCA equals lowest common ancestor, I didn't mean to copy that whole thing. Lowest common ancestor, lowest common ancestor, and we'll send in the left node as well as P and Q. Now we're kind of off the screen again. All right. Wait. Sorry. No. What we want to do is tree node, and we'll call it something like LCA left equals lowest common ancestor, root left, and we'll send in P and Q. All right. And we don't need that. Take this off. So copy and paste gone wrong here. But this one I think we can copy and paste. Okay, so we're going to look at the left, and we're also going to look at the right. Left and right, lowest common ancestor, root dot right. Also send in P and Q. Okay. If they both return non-null, now I'm where I want to be. Example 1. All right, so we go here. That's not what we're looking for. We're looking for 5 and 1. So we look in this tree, we find the 5. So that returns the 5. We look in the right subtree, we return the 1. All right, so if both subtrees return non-null, then the root node, the node that we're looking at, is the lowest common ancestor. So let's put that in. If LCA left is not equal to null, and LCA right is not equal to null, return root. We found it. Okay. Otherwise, we're going to get what happens in this example, example 2. We're going to look at the left subtree, and it is going to return 5, non-null. We are going to look in this subtree. It's going to return null. If only one of the nodes returns non-null, then it is the lowest common ancestor. So let's put that in. If they both return non-null, return the root. Otherwise, is there something in here about it's guaranteed to be in the tree? Yes, P and Q will exist in the tree. Okay, I was going to say, if there's not a guarantee that they exist in the tree, this isn't going to work. But since they are guaranteed to be in the tree, we can do this. We can say return if LCA left is not equal to null, then we'll return LCA left. Otherwise, it was LCA right that returned non-null, and so we will return that. Okay. That should do it, with the exception of, I'm not sure if this equal is going to work here, but let's move it over so we can see all the code. All right. Okay. Well, let's try it. We'll find out pretty quickly if compile error. Oh, that's not what I was expecting. Okay, hold on. Line 29. All right, so this opens with this. We've got this. We've got that. We've got that. We've got that. We need one more bracket. Why is that all the way over there? Oh, I see. Okay. So this really should be indented more, and we'll put that there. Okay. Run. What happened? Oh, it's accepted. All right, that's good. If that's accepted, then I feel pretty good about it. Let's submit. Okay, what do we got? 6 milliseconds. Good. Okay, good on the runtime. Good on the memory usage also. Let's see here. Space complexity, O of n. Let's see that. Oh, there's the numbers. Yeah, on the low end there. I don't know. That doesn't usually happen, but okay. So that is the lowest. I always forget the names. Lowest common ancestor of a binary tree. I hope you enjoyed it. Please feel free to like, comment, subscribe, and see you next time.